thank you for the introduction, and also thank you for the invite to be here. I hope you can hear me okay, and you can also see my screen in a second. I'm pulling up the presentation. So thank you all. It's a real honor to be here, and the topic couldn't be more current and important. So it's a pleasure to have the opportunity to talk about this with you. So this first presentation on the panel today will focus on the relationship between emission trading systems and net zero targets in the context of trading removals, and CCUS technologies, as we will see in the presentation, are a big and crucial part of this. Before I dive in, a quick word about ICAP. So ICAP is an international forum of 14 different national and subnational governments that get together to work together on the implementation of emission trading systems. So they do dialogue on emission trading systems, they do research and knowledge sharing, and they do capacity building, all related to emission trading systems worldwide. And emission trading systems are becoming and increasingly becoming a key tool to drive decarbonization and to reach net zero targets. And we've seen the growth and expansion of emission trading systems worldwide, including in Kazakhstan and many different countries around the world. And at the same time, an equal number of other countries are thinking about the implementation of emission trading systems in the near future. Against this background, we thought it was important to understand whether and how emission trading systems could have a role in incentivizing removals and negative emission technologies broadly, and CCUS technologies specifically. So we wanted to find out more about this issue. And last year, we did a study that looked at the potential of emission trading systems to incentivize removals technologies, including CCUS. Just as a quick note of context on the different options to reduce, avoid, and remove emissions that are out there. As you see on this graph, a key determinant is whether carbon is stored or not, and how carbon is stored. And depending on this, we classify the different technologies and different methods as avoided emissions, as emission reductions, and as carbon removals. And depending on how CCS and CCU are applied, they can either be on the emission reduction side. So for example, when CCS is applied to industrial facilities, or for example, when it's applied to fossil fuel power plant, or CCUS can be classified as carbon removals when, for example, they are coupled with direct air capture technologies, such as in DACs, or when they're coupled with biomass energy, such as in BECCS. And this is just to say that CCS can be framed in different contexts for these purposes. And so far, what you have now in almost all the different emission trading systems around the world is that you have an ETS, so a market for allowance, and a market for removals, where, for example, also removals units, including CCS, can be sold. And the two things are separate in probably 99% of the cases. And in the market for removals, you have a different set of buyers that can range from governments to private citizens and firms in the voluntary market, and in some cases under mandatory markets as well. And the key difference between the two systems is that under an ETS, you trade allowances to emit 1 ton of CO2. The government is issuing the allowances, and covered entities will have to buy allowances to comply with their obligation. And those of you familiar with the Kazakhstan ETS will be really familiar with this model. In the market for removal, instead, you have certificates or carbon credit that certify and quantify 1 ton of CO2 that has been removed permanently from the atmosphere. Many different project developers and operators of negative emission technologies can supply those credits. And again, those credits and those units can be bought by governments or private citizen firms, either in a voluntary or in a mandatory way. So while the two things are separate for the time being, we wanted to understand what was the potential for emission trading systems to act as a way to stimulate the uptake of removal technologies as a whole, and including CCUS more specifically. So we came up with 4 different models for whether and how emission trading systems could be a way to incentivize negative emission technologies. And the different models are different ways to configure the two systems, all the way from model A, which represents a disconnected market. So this is basically the situation you have today in the vast majority of cases, where you have an ETS that operates on one side, a market for removal on the other side, but the two things are not interconnected. And the main disadvantage of this model is that the emission trading system does not create any demand for removal units, or does not create any demand for CCUS, for example, because the two things are separate, and CCUS or other removal units will need to rely on other forms of incentives or policies to basically be profitable. The second option, moving towards a more integrated market, would be to think about a connection between the two markets with the role of a government that would basically act as a middleman. So, for example, the government could buy and procure removal units. So, for example, coming from BECCS or from DACs, and then make them available to covered entities. The advantage of this model is that the government could control the inflow of removal units. Under this model, the ETS does start to create demand for removal units. And the government can act as an entity that bridges the price gap between the ETS prices and the prices needed to make, for example, CCUS profitable. And we know that as of today, the price of allowances in most emission trading systems and the carbon prices that would be needed to make CCUS profitable are still very different, and there is still a price differential between them. So under this model, for example, the government could implement carbon contract for differences or other policy tools to support the development of CCUS, and then the demand for those units would still come from the ETS. Again, moving towards a greater level of integration, you get to model C, which is connected with restrictions, meaning that the government no longer is a middleman between the two markets, meaning that does not have an active role in for example, bridging the price differential, but simply put some restrictions on the amount of removal units that can be allowed in the system. And the advantages of this model are more or less the same as the previous ones. On the plus side, you have less of a burden on the government, because obviously it doesn't have to play that bridging and financing role as in model B. But the downside of this model is that the feasibility of negative emission technologies, so for example, the feasibility of CCUS is then exposed to a price risk. it really depends on the price that is generated in the market, because you don't, in this model, you don't have a tool that could compensate for the price differential. And then we get to all the way to a fully integrated model where the two markets are fully connected and there are no restrictions. And here the main advantage is that the two markets can work together in a seamless way. You can have full integration between the two markets. But again, the main downside is that if there is still a large price differential between the allowance price in the ETS and the price that is needed to make CCUS viable, for example, again, there you don't have a way to bridge that gap, and allowance prices might only get to a level where they actually stimulate the uptake of CCUS at the later point in time. So summing things up and coming to a conclusion, there are a lot of considerations that come into play when you think about how to integrate removals. So for example, CCUS under an emission trading system. So for example, you need to think about what is the right balance between the abatement that is generated under the ETS and the removals that you will procure, and that is a balance that can change in the different models I've presented. You do need to make sure that the use of removals does not detract or does not displace abatement under the system. If the two markets are kept disconnected, then the question is who should then pay for removals? Is it the role of the government, or are they procured through a different system? Obviously, as in all climate policies, the environmental integrity of removals units is key, and there are also challenges with dealing with very different cost profiles among different negative emission technologies. So, for example, as we know, removals through forestry activities and removals through direct air capture and CCS have really different costs today, and if you want to equally promote them, you do need to find ways to bridge that price differential. And then you have other questions related to then how an ETS can really get to net zero by integrating removals, and how then a negative cap can work. More on that on the report if you're interested, but I'll keep it to this for the time being. Thank you.